Our headquarters is in New York, and our R&D center is here, not far from here in Tel Aviv. We got a bit more than 35 employees, and we won many awards on our technology. So everybody knows about the fact that the big data is out there and the tsunami of data is coming to kill us. I just wanted to focus on the fact that it used to be simple to handle data, right? So there was a giant Oracle that completely controlled the large data sets during the 90s, and then SQL Server with Microsoft came and democratized large data set for most of the companies. And a bit later, MySQL came and even made it simpler and easier and cheaper to do that. But what happened with data is the amount of data became so high, it became impossible to be effective with databases like Oracle, SQL Server, MySQL, Postgres, and whatever you guys tried to do. At a certain point, the data is too much for these types of data sets, and then came new technologies like everybody knows, like NoSQL, Hadoop, and plenty of others. What we try to do with SqreamTech is to enable to work on very large data sets in SQL and still be very fast and be able to ingest 30 terabytes of raw data a day, 100 terabytes of raw data a day, stuff that is, as we see in the market today. Our secret sauce is that we're using GPUs. A GPU is a chip made for gaming, for video rendering, for picture rendering. It has thousands of cores, and we found a way to use GPUs instead of analyzing movies to analyze data sets. That's the whole trick. It's not easy to do that, and we're very proud that we actually succeeded in running a SQL statement on a GPU, because GPUs are made to run vectors, which is not exactly like structured data. It's actually the opposite. So usually when you go to customer, and I'm going to stop talking about customers and technology in a minute, they are using something coming from either IBM, Oracle, or Teradata. It's a large server with a lot of CPUs to crunch the data, and we're using a 2U server coming from Dell with a couple of GPUs to crunch large amounts of data. And in a moment, I will talk about how miniature can our solution be, because some of the big data problems, you can't have more than a small card embedded into a car or into a drone, and we'll see a couple of examples in a moment. So this is where we make money. We go to customers that have one of these giants that cost between $4 to $10 million. We come with a server from Dell, with software from SqreamTech. It costs you only $300,000, and we have a customer. So this is how we make a living. Now let's see why we actually started this company. So my colleague in the earlier lecture talked a lot about genome sequencing and how big the data sets here. So the biggest data sets that we see in the markets are in the genomics space. And we collaborate with Sheba Medical Center, that's not far from here, in about 10 kilometers from here. They have a very large cancer research genome center that is trying to analyze sequences in order to compare the ratio of better treatments for people who have cancer. And they compare the exact anomalies from people who have cancer with a certain anomaly and people who don't. I'm not a big genome expert, but I can tell you that the data sets are enormous, and stuff that took them 2 months to do, sequencing and research comparison with sequencing, took them 2 months on 12 sequences. We did the same thing about hundreds of sequences, and it took us 2 hours. It's a huge data set. They bought storage for 1 petabyte, and their plans are to do comparison of tens of thousands of sequences. Every sequence is more than 200 gigabytes of actual rows in the database. So they try to do it with Hadoop, and they try to do it with MongoDB, and they try to do it with every single thing that moves on the planet, but they need to do a join, right? They need to do a join between 6 tables, and that became extremely complex and almost impossible to get the results in a normal time frame with other technologies. So this is something that we're really proud of. And of course, if we find queue to cancel faster, more people will be healed faster, and that's great. The other cool stuff that we do is with drones. So a drone is a very nice hardware, but it's a big sensor. Everybody understands there's nothing to do with drones without analyzing the data that comes from here. It has about 4 cameras and quite a bit of other sensors, and they, at least in this use case, Homeland Security use case, they stream the data into a caravan in the field, or a car in a city center, or a laptop or a mobile phone with someone that is moving, right? So in this use case, 5 drones are going on top of a border, sending data to a caravan, and someone in the caravan needs to understand if there is a dangerous situation around the border. You can't put a Teradata in that. You also can't put a cluster of 20,000 Hadoop machines in that. You have a space for 1 or 2 servers there. So we put SQream inside. We ingest about 8 terabytes of structured and semi-structured data an hour, and we keep borders safe. All right, so this is pretty cool. I really like that one. Another use case that is almost the same but different is locating hazards and dangerous situations in city centers, right? So you have someone that sits in a car. I saw that in the movies, and I saw that in that project, okay? Someone sits in a car, and he gets data from drones that are flying on top of a city. In the same time, he gets data from the telecommunication companies that is actually is about where you are right now with your phone. So what we need to do in this laptop, that it's not SQream laptop, it's a Dell laptop with my sticker on it. Okay, so don't worry, we don't create hardware. You need to understand right now if 2 dangerous people are getting too close to each other, or a certain truck is moving in a certain place that is close to a dangerous guy. And they need to spot hazards in real time. And the only thing that you can put there, because sometimes it's someone that sits in Starbucks with a laptop, just next to an event that is happening right now in the center of Central Park in New York. So this is the only thing you have. But you have a GPU inside, and the GPU have hundreds of computing cores, and we use it to crunch. In this use case, it's about 8 terabytes of raw data. So this is cool. And another cool situation is what we're trying to do with the autonomous car space. So in autonomous car space, there are a huge amount of sensors. We do not do videos. It's not our game, it's Mobileye game. We are in the structured and semi-structured data game. So we are trying to enable the car manufacturers to analyze in real time all the data that is streams from thousands of sensors inside the car about the engine, brakes, air condition, blah, blah, blah. Plenty. And there's a lot of sensors and a lot of data points to collect and analyze in real time. So you're not going to put a rack in a car, but you are going to use something like that. That's in the size of 2 smartphones, this card. It is called the Tegra X1. This is the size, double of iPhone, not 7, iPhone 6 Plus. It gets DC. Inside, you can put an SSD of up to 4 terabytes inside that one. And because of our compression algorithm, we can actually analyze 20 terabytes of raw data in real time in the car. Just because this little thing, which is very small, has 280 computing cores. Okay? They are created in a very high parallel way to analyze vectors, and our IP is to use the same technology to do big data crunching. So you put one of those in the cars and you have real-time analytics. And that's in addition to all the data that goes to the cloud and back. Some of the things they need to analyze there need to be done in real time. So this is a few cool use cases we're doing with SQream. I'm happy to answer questions. No questions, it's all clear. Thank you.